Okay, in this program we input a 4-bit sequence. That 4-bit sequence is actually one of the mounted gray code on this black disk. This disk has 16 unique positions. This program actually enables us to stop the gray code disk at any desired code at the reference position. What is the reference position? This reference position is actually the assembly of the phototransistors and LEDs mounted to the motor's body. Let's have a look at the reference position. We can see the reference position, which is actually the assembly of the phototransistors with LEDs mounted to the motor's body. Let me stop the disk at the position first. First we must know that the program reads the initial position from the disk in outward fashion, means the first bit is read from the point near to the shaft. In this way 4-bit pattern moves in outward fashion. Now let's stop the disk at the position 1010. For this we need to feed this pattern to the program. Let the red spot is on the required pattern to be positioned at the reference position. Make sure that your I have positioned a red spot. I have marked the required position. This position is required to be stopped at the reference position, which is marked by the red spot. Okay, once I have set the pattern, it would start the rotation. Oh, I think there is a problem. Make sure that your shaft and the disk has no obstacles. Unlike us, we do have some kind of wires and so try to make neat connections. Otherwise you may have some kind of unwanted obstacles between the shaft or within during the rotation. So try to make some neat and clear connections. Let's demonstrate it again. So again, let me mark the new position, that is 0110 with the red spot. Initial position read from the phototransistor assembly at this point is 1010. It means the disk will start rotating from the position 1010 to the position required, that is 0110. The required position is marked with the red spot and the reference position is fetched by the program from the phototransistor assembly, and that reference position is 1010. Okay, and the position required to be stopped at the reference position is 0110. Okay, let's start the program, and here we go. So that was the technique to interface the stepper motor with the program written in a C language through the printer port. Okay, now let's take another position. Let me have my red spot again. Here we go. Okay, now let's take another position. Say this position is 1010. I have marked this position 1010. This position is required to be stopped at the reference position. So let's feed the new position on the gray code, which is required to be stored at the reference position, to the computer program. This is 0110, and as you see that a new position on the gray code has been stopped right in the reference position to the computer program. In this way, once the 4-bit sequence is given to the program, it drives the motor, and when the required sequence on the disk is positioned at the reference position, phototransistor assembly sends the signal to the printer port, which is fetched by the program. The program then compares both the sequence, one from the user and other from the phototransistor assembly. This comparison enables the program to stop the disk at the required position specified by the user. Now let's have some look at the hardware assembly of this project. This hardware includes a simple 4-pole stepper motor. Would you please take the camera of the stepper motor? Okay, now you can see this stepper motor is a simple 4-pole stepper motor. This stepper motor is derived with a 4-word sequence where each word constitutes 4 bits. I repeat, each word which is used to drive the stepper motor constitutes 4 bits. These bit patterns include 0011, 1001, 1100 0110. Each pattern is used to move the motor shaft by 1.8 degrees. It means 4 of these consecutive patterns would then drive the shaft about 7.2 degrees. So 1.8 is the step size. To drive the motor continuously, we simply require to repeat these 4-bit patterns cyclically. Means the first pattern 1001, 11100, 0110, 0011, then again 1001, 1100, 0110, 0011. In this way, we can rotate the shaft continuously. To this stepper motor is interfaced with the printer port through ULN 2003 IC. This ULN 2003 IC is biased with a 5-volt through a Zener diode. Okay, this is the ULN 2003 IC. The input to this ULN 2003 IC comes from the buffer 74244 IC, which is directly connected to the lower 4 data pins of the printer port. Why we have used a Zener diode to bias the ULN 2003 is because to avoid any kind of the fluctuations that may break down the motor. Okay, the upper 4 data pins of the printer port are connected to the buffer 74245 IC, which is used to take input from the photo transistors. So this is a simple assembly with a ULN 2003A, buffer 74245 IC and a buffer 74244 IC that is interfaced with the printer port through a program written in C to drive the motor.
A group photo.
This project has been prepared by the student of GC University Lahore, BSc 06 is our session. My name is Mohammad Imnis.
That's my name is Sayyid Qasim Abbas.
My name is Zuhair Zafar and he is Nirpur.
Hi, I am Nida.
Okay. That's it.